Did you know that your brain, the most powerful organ in your body, which controls every thought, every movement, and every sensation, cannot feel pain itself? While it is responsible for interpreting every painful signal coming from your skin, muscles, and internal organs, the brain tissue contains no pain receptors. This astonishing fact explains why surgeons can operate on patients who are fully awake without the brain feeling a thing. It also makes us question everything we thought about pain, sensation, and the incredible design of the human body, showing that our perception of pain is as much a creation of the brain as it is a warning from the body. Pain is far more than a simple discomfort. It is a complex and vital warning system designed to protect your body. Specialized nerve endings called nociceptors detect tissue damage, extreme heat, pressure, or chemical changes, and send electrical signals through the spinal cord directly to the brain. While nociceptors exist throughout muscles, organs, and skin, the brain itself contains none. This clever biological design ensures that your brain can process vast amounts of sensory information without being overwhelmed, allowing you to react to threats efficiently while performing higher-order thinking and problem-solving. Even though the brain itself cannot feel pain, it is the master interpreter of all the body's warning signals. When nociceptors in your body detect damage, such as a burn, a cut, or a broken bone, they send electrical messages along nerves to the spinal cord and finally to the brain. Regions like the thalamus, somatosensory cortex, and anterior cingulate cortex translate these signals into conscious sensations we recognize as pain. Essentially, your brain creates the experience of pain from information it receives, but the brain tissue itself remains completely unaware of the injury. The brain's lack of pain receptors is likely an evolutionary advantage. Encased within the skull, cushioned by cerebrospinal fluid, and protected by membranes called meninges, it is already insulated from most physical threats. If the brain itself contained pain sensors, even routine activity like thinking or slight pressure changes could trigger continuous discomfort. Instead, pain receptors exist in surrounding tissues such as muscles, nerves, blood vessels, and the meninges, which are more exposed. This arrangement ensures the brain can focus on essential functions without distraction, interpreting signals from the body efficiently. Headaches can feel like the brain itself is aching, but in reality, the pain originates from surrounding structures. Blood vessels, meninges, muscles in the scalp and neck, and nerves such as the trigeminal nerve all contain pain receptors. When these tissues are irritated, inflamed, or tense, they send signals to the brain, which interprets them as pain inside the head. This is why migraines, tension headaches, and cluster headaches can be so debilitating, even though the brain itself remains completely insensitive to pain. Understanding this helps doctors target treatment to the actual sources of discomfort rather than the brain. Pain is essentially a message system from the body to the brain. Specialized nociceptors detect harm, such as heat, sharp objects, or chemical irritation, and convert it into electrical signals. These signals travel along peripheral nerves to the spinal cord, then up to the brain. The brain receives and interprets these signals, transforming them into the conscious experience we call pain. The fascinating part is that the organ responsible for creating this sensation, the brain, never experiences the pain itself, allowing it to focus on processing information and coordinating survival responses without being overwhelmed by the very signals it interprets. One of the most remarkable demonstrations of the brain's lack of pain receptors is awake brain surgery. Surgeons operate on patients who are fully conscious, testing functions like speech, movement, or memory during the procedure. The scalp and skull are anesthetized, but the brain itself feels nothing. This allows surgeons to carefully remove tumors or damaged tissue without affecting essential areas of cognition or motor control. Patients often report minimal discomfort. This procedure highlights the brain's unique design and shows how humans can safely interact with one of the most vital organs in the body, while it remains completely unaware of pain. Headaches are caused by irritation or tension in pain-sensitive tissues, not the brain itself. Tension headaches result from tightened scalp and neck muscles. Migraines involve abnormal blood flow, nerve activation, and inflammation in surrounding tissues. Cluster headaches follow cyclical patterns involving nerves around the eyes. In all cases, signals from these tissues are interpreted by the brain as intense pain. Understanding this distinction allows physicians to focus treatments on muscles, nerves, or vessels rather than the brain, providing more effective relief while emphasizing how the brain processes signals without ever feeling them directly. Migraines are one of the clearest examples of how the brain interprets pain. They often involve abnormal activity in the trigeminal nerve and changes in blood vessels that activate surrounding pain-sensitive tissues. Symptoms can include extreme light or sound sensitivity, nausea, and pulsating head pain. Despite these intense sensations, the brain tissue itself remains untouched. Studying migraines offers valuable insight into how neural circuits, blood flow, and sensory processing interact, and demonstrates that our perception of pain depends not only on the body's signals, but also on the brain's interpretation and amplification of those signals. Pain is not only physical, it is deeply influenced by emotions and cognition. Stress, anxiety, and previous experiences can amplify sensations, while relaxation, meditation, and mindfulness can reduce perceived pain. The brain integrates these emotional and cognitive factors with incoming signals from nociceptors, shaping how pain is experienced. This explains why two people with the same injury can feel pain very differently. Understanding this connection emphasizes the brain's critical role as both interpreter and regulator, showing that the experience of pain is a combination of body signals and mental processing, not just tissue damage. There are many fascinating real-life examples that show how the brain interprets pain. During awake brain surgery, patients can talk, move, or solve puzzles while surgeons remove tumors because the brain itself cannot feel pain. Brain freeze from ice cream occurs when nerves in the roof of the mouth trigger pain signals sent to the brain, not the brain tissue itself. Even conditions like hydrocephalus cause headaches from pressure on surrounding structures. These examples illustrate that the sensation of pain is shaped by signals from the body, interpreted masterfully by the brain. The absence of pain receptors in the brain likely provides an evolutionary benefit. Encased in the skull, cushioned by cerebrospinal fluid, and protected by membranes called meninges, it is already shielded from most threats. If the brain contained pain sensors, even minor pressure or blood flow changes could create constant pain. Instead, nociceptors exist in tissues more exposed to harm, like muscles, blood vessels, and meninges. This clever arrangement allows the brain to focus on thinking, coordination, and survival without distraction from its own sensory overload. Although the brain does not feel pain directly, we can influence how it processes discomfort. Proper sleep, hydration, stress management, and gentle stretching reduce headaches caused by tense muscles or inflamed tissues. Migraines can be minimized by avoiding triggers like certain foods, bright lights, or dehydration. Understanding that pain signals come from surrounding tissues allows targeted prevention and treatment. By caring for both body and mind, we help the brain interpret signals more efficiently, reducing unnecessary suffering and improving overall nervous system function. Despite controlling every sensation, thought, and movement, the brain cannot feel pain itself. Pain originates from nociceptors in surrounding tissues, which send signals the brain interprets as discomfort. This design allows the brain to focus on complex tasks, decision-making, and survival, without being overloaded by its own signals. Awake brain surgeries, migraines, and even everyday headaches reveal this remarkable paradox. Understanding it provides insight into biology, medicine, and the extraordinary efficiency of the human nervous system, reminding us of the incredible design of our own bodies.